Hi everyone, it's Michal here, and I'm super excited to show you a new feature of Siml.ai beta. It's called parameterized simulators. What it means basically is that you are now able to add a parameterized input into your simulator, meaning that you can train the simulator for the range of inputs. So let's say we want to simulate a water flow through a water tank. This is a very simple use case, and also the simulator is pretty basic. It has few geometries that is combined together to form a water tank, which has one input right here, two outputs right there, and what we want to simulate here is a water flowing through this input, mixing inside or just flowing, doing some various shapes and flowing out. And what we want to do is to test different speeds of the inflow of the water. So if you want to do it in traditional simulation software, you would create various or multiple simulations with different boundary conditions for the inlet. For this simple case, it will take you just a few minutes, of course, so it's not a big deal. But what if you have a very complex shape and a very complex type of the simulation you want to do? If one iteration will take you a week to complete, then you need to reconsider what you want to do, or if there's no better way to create multiple simulations but in shorter amount of time. And that's where AI-driven simulation shines. So that's why we are very excited about this feature. So what you can do now is to specify not just one input or one boundary condition, or meaning like one speed of the water that is flowing in, but you can say like, I want to test the flows of, I don't know, 0.5 meters per second to 10 meters per second. What will happen? And just specifying a minimum and maximum value for this parameterized input, the simulator will be trained for all of the inputs in between. I will show you in the simulator itself, in the visual editor. So before, if you went into a neural network node, you would see just a specification of the name of the input variables and output variables. So the inputs are just the positions, X, Y, Z points, and the outputs here in particular are velocities in X, Y, Z direction, so U, V, W, and pressure. But here, there's a new interface for parameterized input variables. And as I've said, what we want to parameterize here is the inflow of the water. So what you need to do is to specify a symbol or a name for the variable. So like here you can see, I name it inlet velocity. Already have inlet val here. And if you add it, it will be just added into the list. So you can specify a min and max values like this. But we already have one, so I will just go with it. And what we did here is that we specified that we want a inlet velocity into the input be trained for the simulator between 4.1 meter per second to 0.3 meters per second. And why we added a negative value here? Well, of course, if you're considering that the position or the normal of the z-axis is pointing up, then what we are interested in is water flowing down into the water tank. So that's why we are adding a negative value. So it's pointing in the z-axis down. So that's why you need to add also negative values if it's pointing in that direction. But this is not only thing where you can add your parameterization. You also can parameterize equations and all of the variables inside it. So here again we already have a Navier-Stokes equation with the kinematic viscosity parameterized for different values between 0.001 to 0.03. You can also parameterize other variables by clicking on this checkbox, and this will create a parameterized variable out of it. And now what you need to do is to specify the min and max values. Make sure that the min and max, or make sure that the default value, which is just used for like a default value in inferencing, is within this range. If you don't want this to be parameterized, you just uncheck this value and it goes back to being just a scalar. Okay, so now, as we've shown, you can parameterize any input into any type of the equation, and also add your own parameterized variables here into the neural network node. So what to do with it? You need to parameterize your simulator by selecting these parameterized input variable in the constraint node. So you basically use the variable somewhere. Now, other nodes are the same as they were before, so we're specifying all of the constraints for the boundaries, for the interior, for the outflow, which is just a pressure to be 0. But here in the inlet, that's what we want to parameterize, or like a boundary condition to it. We want to parameterize the inlet velocity of the water. So before, there was just one value, like we specified 1.5 meters per second in the negative z direction, and the simulator could only return values or the simulation outputs for that velocity. But now we added an option to use variable parameter, and this will show you all of the variables that you added to the neural network node. So it already knows about this variable. I can just select it, it will pre-fill it where I want, and now when you save the simulator, it will be there, and basically now you have a parameterized simulator created that easily. Now, I want to show you how this actually works when the simulator is trained. So I prepared in the environments an environment which uses the simulator. It's been training for some time. You can see for 3.2 days, so 78 hours, but on the lowest tier that we have right now, just to showcase what it can do. The simulator itself is pretty accurate for the setup we have, so we might not have used the completely accurate model for the physics part, for like Navier-Stokes PD, but we used what is just implemented so far in Siml.ai. And by the way, very soon you will be able to add your custom equations, but I will not speak about that right now. So let's say we want to test an inference on the simulator. Now you can do it very quickly, so you don't have to kind of go to some, I don't know, an UI where you need to download the output and render it in your software like ParaView. But you can go to an inferencer app we have right here, and this will preload a custom application that is bundled in each environment for you. And right here, you can see that we have a bunch of options here. And by the way, also in next iterations of Siml.ai, you yourself will be able to create these types of applications. because I know that a lot of you might have different use cases. You want to showcase it differently or add some additional explanations about your simulations, and then you want to kind of share it within your company to different teams, etc. But yeah, we'll be creating an engine for you to create those apps. Right now, this is it. This is the bundled one. Each of the environment has it. So what you can do here is that you basically can change the resolution of the output. And this is a very simple slicer app, which slices the simulation output for you. So you can see, like in 3D, where the slices are. Then you can see each slice here and investigate the values that you selected, or variables, output variables that you selected here. And you automatically have all of them listed here, so you can just change, like, okay, what might interest us the most is how is the velocity in z direction, so basically the w part. And I encourage you also to always click on the rescale, because we want to rescale the output within some range, so it's not outside and doesn't show us incorrect values. So here it is how it might look, the simulation output, and what you can investigate here is that you can change the slide, the slice, and kind of showcase different parts of the simulation domain. So very quickly you can do this and change the visualization. But what might interest you the most is to leverage this new parameterization of the simulator, meaning that you can change the value that was pre-trained for you. So right now, since we have a default value set to -1.5, if we change it a bit and then run the inference, basically simulating or re-simulating the model, you will get the output, the new output, within a few seconds. Again, you need to click on the rescale here in this application to show the new output. Okay, so you have the information here again. If I now change it to different value, run the inference, and you can get the simulation output within few seconds here in the application, in the inferencer application for you. This doesn't mean that you are constrained to use the inferencer app. You can download a output in the VTI format, which you can then use in ParaView. But let me get back to the interface in the environments. So not just that, not just use an inferencer app, you can also right now go to the Simulation Studio. This should be available for everybody who is on the standard plan and above. So right now here the demo account has it, so I can showcase you how it looks like. So now what you can do is to go to the Simulation Studio. It will connect to the instance, and you can see the simulation output in your browser, which has higher fidelity, and you can do much more with it. So let me show you how it looks like if you do an inferencing here in the Simulation Studio. So if I change the input value and click on Simulate, you will get the value again within a few seconds. You can test different values, change the inputs, and get the simulation output in seconds. But here, what is really interesting is that you can change the type of the rendering of the points that you get out of the simulation. So what I'm really excited about is this last one. You can showcase an animation of the velocity magnitude. So this is how you can play with it and try different types of renderings. And also what you can do is to change the resolution of the output. So basically the amount of points that you're rendering. So if I change this to be different resolution, also change the inlet speed, again, the simulation will take you a few seconds, but you will get more points. And it will show much more information. Right now we have this issue of disconnecting, which will be fixed in the next version. But basically what you can now render is the amount of points that will give you much more information about what is happening inside the simulation output. Okay, so basically this is a parameterization feature. You should be able to test it in each of your simulations. And basically what you need to do is to update your simulators or create ones with the parameterized inputs in the neural network node. So I'm really looking forward to know how you leverage this feature, and yeah, good luck with that.